And greetings, it's Mr. Banks or Mr. Anthony Banks. Mr. Banks if you're a student, and Anthony or Banksy if you are a teacher. This is the first of a series of videos for students and teachers in the Gateway Aerospace Schools in Queensland, Australia. And it's all about building a drone. And so we're going to start off by having a look at the components of a drone and then go through all the different systems and subsystems, and then we're going to tie that in with the objectives in the QCAA syllabus, aerospace systems. So for this I'll be using different resources. We've got down here, we've got our vertical camera that we can show different parts of a drone. And also we've got the front facing camera where we can show other components and things, as well as OneNote just up here where we can actually take notes and do the curriculum side of things as well. So let's get straight into it. Here we have just a typical small drone. This one is a Cinewhoop. It features a video camera, an FPV camera, and a recording camera. So an FPV camera for viewing through video goggles, some sort of video receiving device, and a camera for recording onto SD card, which is in there. This drone, let's go through the components, and then we're going to pull apart another drone. Well, actually it's already pulled apart. And then put it back together again. Okay, so typical drone. We've got our frame, so we've got a top plate on this one just here, and a bottom plate just here. This is all one piece. This particular one, you can see that the arms and the base, the bottom plate are all one, carbon fiber. And you can get drones that have got separate arms, and so your students out there can think, what are the advantages and disadvantages, evaluation, place judgment on having what it's like to have different arms. I won't tell you here, that's for you and your teachers to decide. Same with this kind of square structure of a drone. What's the advantages and disadvantages of that? So you can even start mind mapping out and developing some ideas, on what's a good shape for a drone, because there's lots and lots of different shapes. What else do we have? This one's got guards around here, prop guards. You don't necessarily need those. They do hinder performance a little bit, but they're nice and safe. They're not bulletproof. I've broken a few of these in my time. We've got electric brushless motors here, and we've got propellers as well. And we'll go through all those particular subsystems when the time comes. In the middle, we've got our flight stacks. This is divided up into two different stacks here. It's got a Wi-Fi board on top. Most important part's a flight controller sitting down inside here, and you'll see that when we break the thing apart. And there's also a video transmitter board in here. The Wi-Fi board actually is integrated in with the recording board, so you can see the SD card sitting in there. It's the Wi-Fi board, so I can talk to it on my phone and can change parameters on it, change video resolutions and things. Got a strap to hold the battery on. Battery will go here on top, that way. Connect, power in, just down the bottom here. Little tiny plugs, and we'll talk about those little tiny plugs. And we've got on the bottom the receiver, just in here, and connected to the antenna up here. And you have different types of antennas, and that'll be different videos on antennas and the importance of them. Receivers will be a different video as well. There's our basic system of our drone. So let's go over to what we'll be building. We have the components of our drone here, all carbon fiber, and that's going to be, we'll start by putting everything together. Move that out of the way. Here's the components that that came out of. And I'm going to basically explain the basics of this particular system. Things will get a little bit messy, but we'll have some fun doing it. Okay, down the bottom here we've got 4 brushless electric motors, connections. This board here is called a power distribution board, and it looks like it's central to the whole thing. I guess in a way it is, but really I would consider this board up here, the flight controller, is the most important part. That's really does all the thinking and all the calculations of the settings of the angles that the aircraft, that the drone is at, I'll call it the aircraft, is at, and will feed information to the brushless electric motors here to power them up or power them down. Okay, so that is what I would consider my main central part of the board, the flight controller, or FC. Let's go through what's connected to it. Okay, so down here you can see I've got solder pads. Be very careful because it's quite fragile. Get some focus. You can see that those wires come in and solder to each of those little tiny copper solder pads. So we'll be very careful when we're soldering onto those, because it's easy to apply too much heat and burn those pads off, and once they're gone, they're stuffed. You can't fix them. The teachers, you have to be really, really... Wait for focus. Wait for focus. Teachers, you have to be really careful with allowing students to solder onto these tiny, tiny solder pads. Now my stylus here, it's about the size of a pen, a normal biro. So you can see the relative size of how tiny they are. And sure, some students can. Certain age groups, you'll have to make that decision yourself. What sort of practice students will do. So here we are. That's the flight controller soldering onto there. You can see it comes down here and just connects via a plug. That's what I purchased all this with. It came with these connections. So it was intended to plug in there, and it was intended to solder onto there. And I'll show you the links to these. Also off the flight controller we have our FPV camera, first person video camera. Once again soldered on. And we'll talk about what the coloured wires mean and what these inputs are on the flight controller. That little cable there coming out of this FPV camera is just for plugging into this little kind of dongle, this little thing that's that's got a little kind of gimbal on it, a little stick that you can configure parameters. You move the stick backwards and forwards on it to configure the parameters of the FPV camera. I don't think I've really touched it. Lens cap, keep it on when you're not using it. And that particular camera is a low light camera too, so you can fly in the evening and it would enhance the light that's out there. So coming in here is on our flight controller. Remember I said that everything hangs off the flight controller. We've got our video transmitter, VTX, just here. And the antenna would clip on just in this little clip here. Very, very tiny. Focus. Not going to happen. Just there. And it's got a tiny, tiny little connector. If you listen carefully enough, you'll hear a little click, and that will click on there. There it goes. It's got heat shrink. This VTX has got heat shrink around it to insulate it. I've cut parts of it off just down here so that I can clip on that with that video antenna just there. And we'll talk about the types of antennas there are too. So put that off to one side to get everything organized again. Just gets a little bit messy. Trying to be very careful with it. What have we got? We've got flight controller coming down to the power distribution board. I'll get back into the PDB soon. FPV camera, we're flying with FPV goggles. VTX, video transmitter and antenna. While I remember, never power anything, these systems up without having an antenna on. If that's transmitting, always put an antenna on, or else you'll pump all that energy, that power into the board, and there's no way to dissipate it through the antenna, and so it'll overheat and burn out. So always have an antenna on. Now, connected to the flight controller at the appropriate spot, and we'll talk about where you actually solder on, is the receiver. Now this particular receiver is an interesting little fella. Again, this is a whole video that's needed for itself, but for the moment we're just talking about what are the components. So receiver that will pick up the signal from the transmitter, just here. Okay, and you can see that it's the same kind of antenna, and once again transmitters will be a different video, but we're just talking about the overall system at the moment. In systems thinking terms, habits of a systems thinker, which your teachers will take you through, this would be big picture, the big picture of things. So this is transmitting, like I'm transmitting to you my voice, and the receiver just down here, the receiver is listening. Without getting too complicated, that's like your ears listening in, and the transmitter that I had just a couple of seconds ago is like your voice. Now, having said that, these modern receivers can also transmit back to the transmitter. Okay, so you could call them like a transceiver. They transmit and receive. But because this is capable of transmitting as well as receiving, I must have my antenna on, like I said before, or else I'll burn it out. But for our big picture, to keep it simple, let's just call it a receiver. It's just listening into any stick inputs from the transmitter that the pilot will command, say left roll or left yaw. Just go through it by point. You can name. That is my flight controller, FPV camera, receiver, oops, not receiver, video transmitter. I said receiver just to see if you're listening in. Video transmitter, abbreviated, VTX, any transmitter is TX. Antenna, here's the receiver, the RX, receiver, RX, antenna. What's this one? Power distribution board, PDB. Getting back to our flight controller, FC. I've got a GPS attached to it, just here, tiny little GPS. Once again, the plugs that are supplied with it, coming in, so being soldered onto the right part of the board. The instructions tell you where to solder things, and then that's also set up in the software, which we'll talk about later. We're just big picturing this at the moment. Good. We've got flight controller connecting down here to our PDB. Notice it's got 4 connections. We've got 4 motors. This is a quad rotor, and power comes in through the main power lead. And this little tiny plug here called an XT30. It's small, and I've got a matching plug on my battery, XT30. For the bigger aircraft we fly, their plug's bigger, they're XT60, and you can get really big ones called XT90. and you can discuss with your teachers why you'd have a bigger plug or a smaller plug. Obviously, this drone here is meant to be sub 250 gram, which is significant from CASA's point of view, CASA, Civil Aviation Safety Authority. And you can do some research on the whole concept of sub 250 gram and why DJI made some of their little drones, like the Mini 2, why they made it 249 grams. What was the decision behind that? The power comes in through the XT30. There's a capacitor there just to filter out the signals. A lot of noise comes in, electronic noise with the power, so that filters some of the noise out, and then power gets distributed out to the 4 brushless electric motors. You can tell they're brushless because there's 3 wires. Okay? So this power coming in is DC, direct current, but brushless electric motors are switched. There's coils in here, copper coils that are energized and de-energized rapidly, and it's AC, alternating current. So DC comes in, but AC comes out, and there's something in here that does that. We'll talk about speed control, electronic speed controllers at a different time. So that's it. I think I should add on the flight controller, very specialized piece of equipment. You don't need to get into all the electronics, this is not a course on electronics, but you will have on here gyros and accelerometers. So you can do some more research, but very quickly, a gyro measures rate or roll. Now what does rate mean? Rate means it means speed, how fast something happens. So rate of roll, how fast it rolls about an axis. 100 degrees per second, 360 degrees a second, maybe more, maybe 720 degrees a second, 2 complete rolls. The gyros measure that. So if the aircraft's, and they measure it in roll, in pitch, and in, what's this one called? Yaw. It's called yaw, Y-A-W. And gyros can measure that, and therefore, if the aircraft has been hit by a disturbance, and it rolls one way or pitches another way, or even yaws, it's constantly being hit by disturbances in the air, then it can send a command. The gyro recognizes that it's been knocked out of equilibrium, so it's not hovering nice and horizontal, and it can send a command to the motors, to certain motors to throttle up to bring it back into level flight, into equilibrium. And I don't know whether we'll talk about PID control loops. Perhaps we will, it depends on time. But how that all happens, how the flight controller, through its gyros and its ability to measure acceleration through accelerometers, which is a chip on the board somewhere, how it actually can detect things happening around it and compensate for them by commanding the motors to spin up faster. So, but that's not the purpose of this video. This is just talking about the whole drone system. So I'm going to move that out of the way. Other parts to it. Things rolling around my desk here. Be very careful. Obviously we're going to have a bunch of connect screws and nuts and bolts and these things called standoffs. Okay, because we've got a certain distance between top deck and lower deck. We've got to mount our electronics on board. When you stack them up one on top of the other, like in this one over here, let's see if we can get in there. You can see them just. I have three or so boards. They're called flight stacks. You can buy a flight stack to have everything nice and concise, because real estate, which means room, is our problem on these smaller drones. The bigger the drone, the more room there is, and the smaller the drones are, the less room there is, and therefore everything's really, really tight. Therefore heating becomes a problem, or cooling it down, it overheats. What else is part of our, let's have a look, we've got these fellas here. propellers. Okay, just wings really that turn. On most drones, they will be the propellers will rotate like this. Okay, I call it, with my students, I call it a crab feeding itself. If you ever see crabs feeding, they go like that. Most drones, propellers will rotate that particular way. You can see. And they will rotate, diagonals will be the same. Okay, diagonals will be the same. And you can talk to your teachers about how roll, pitch and yaw on a drone are achieved by propeller rotation. Okay, roll, pitch forward, pitch back, and yaw. Yaw left, yaw right. Yaw's the interesting one. Don't hesitate to send me a note too if you don't understand how those things are achieved. That's for the GPS. The GPS is going to sit up in there. We want to get our compass. We want to get our GPS as far away from the rest of the electronics as possible, because the GPS has got a compass on it, or inside it, a magnetometer. So we want to get that magnet well away, or else that magnet will be affected by all the electronic noise that's been generated in the system. The drone needs a compass to be able to fly properly. An aeroplane doesn't, because the tail is generally going to follow the nose in an aeroplane. Yes, you might get a little bit of skid or slip in an aeroplane, but generally the nose goes first, the tail follows. But a drone, it needs to know its heading in order to be able to do coordinated turns. It needs to know which way it's headed. So we've looked at propellers. I'm just having a look here. We're going to start with this. Okay. After I end this video, the second video will be starting to assemble the frame. And then, once the frame's assembled, we'll quickly get into mounting our flight controller. Our PDB power distribution board will go down first. Our flight controller will go on top of that, and our video transmitter will go on top of that. We'll get our motors down and get our receiver, and everything will start to get really, really tight. But it's going to be a nice, small, little sub 250 gram drone that can do waypoint navigation. It'll be a great little drone for learning to hover, because it'll have GPS, which means it'll be able to sit there because it knows where it is. Okay. And I don't know if I mentioned, there's our power system. That's part our battery, which is part of the power system. So it's part of the overall system. You start thinking about your habits of a systems thinker, how everything interacts with everything. And before I leave you, I will let's just go through very quickly, because I'll try to build into this the things that you'll be assessed under, I guess, in the aerospace systems and STEM subjects. They're called the objectives, kind of like the criteria. And the first one is recognize and describe. That's an R. So if I was to assess you on this, if you're doing a folio or whatever, like you're doing senior, if you were to say to me, this is a brushless electric motor, you recognised it. If you were to say this is a PDB, you recognised it. Now when you describe it, the other part of it, you'd say, well, it's a flight controller. Recognise that? This flight controller weighs 12 grams, is 20 mil by 20 mil between mounting holes, and is a blue colour. That's describing it. Notice this is all fairly low level information. It's naming things. But nonetheless, it's very, very important to be able to understand what things are, what they're called, and a description of them. You describe what it does. A flight controller is used to stabilise the aircraft. It's used to command the motors to spin up or down. it's got accelerometers on it, which measure linear straight line acceleration. So there's some of the things that you do for that first objective. The second one is symbolize and explain. That's a P. Okay, so symbolize means you do some sort of graphical drawing of whatever is required. Now, if this was a drone, I want to symbolize and explain a drone, I could just go like this. There's my arms, there's my electric motors, my propellers, and I've done a fail, and there's my flight controller sitting in the middle. I've symbolized it. I'd caption that. I'd put down here, I'd go figure 1 drone system, and then in my text I'd refer to figure 1 when I'm talking about the drone system, when I'm recognizing, describing it. You would not, I'd be happy with that, my students did it, but if they went and ripped a picture of a DJI drone off the internet, like, let's have a look, see if I've got one here. Yeah, one of the DJI drones just like that, and put that picture in there. That's not symbolizing. That's just pulling a picture off the internet that anyone can do. So symbolizing, be able to do some sort of representation of it, and your teacher will be really happy with that. Explaining is now talking about what it does and how it does it. Okay, so what it does and how it does it. Now I know that could come under describing, and it's a fine line, I admit, but you're starting to dig deeper into letting the reader of your document understand what you're telling them about the system, how it does it, maybe a why it does it this particular way, why it does it a way, a particular way, maybe. Okay, so digging deeper and deeper and deeper. The third one is analysis. And we'll do analysis in another video of the system. But for now, these two here are really what we're dealing with in these particular parts in building a drone. So I hope that helps. And we'll see you when we start the build. Okie dokie. See you later.